Hey everyone, today we're going to talk about scatter plots, correlation, and causation. We're going to just keep continuing with the statistics side of it, and today you're provided with a blank copy of notes to write down some definitions and fill in some things. You can use that. Remember, you can always stop and pause this video at any time and write down anything that we need to know. So let's go ahead and get started. Okay, a scatter plot. A scatter plot is a graph that is made up of points, xy coordinates, that represent the relationship between two sets of data, also known as bivariate data, and are scattered around. So go ahead, if you want to pause this right now, you can, and write this definition down. Scatter plots is something I think you've talked about before in middle school. We're going to look at it a little bit differently maybe here. Possibly. So let's go ahead. Let's move to the next slide. So here's an example of a scatter plot. So this is a table, and if you want to pause right now and you can fill in the table with the different pieces of data. This is the minutes of studies versus test scores. So your x-axis is how long you've studied. Your y-axis is the test scores. So pause right now, go ahead and fill in your table, or not table, but the graph. So if you look here, this scatter plot describes the relationship between minutes studying and scores on a test. So as the time is spent studying increasing, the test scores are actually increasing. So the next question that I have for you is, what would you predict is the test score for someone who spends 10 minutes studying? If you said anything between 59 and 63, I think that is a good estimate. Remember, these are predictions. Later on, we're going to be doing line of best fit using your calculator or the Desmos app. And we could actually figure out specifically, if you spent 10 minutes studying based off of these scores, what would you score? So if you look, I'm looking at 10 minutes, so I'm looking at anywhere like in this little range right here. So, because there could be a line possibly drawn, and that's line of best fit. And we'll be looking at that a little bit later. Okay, so how do we describe correlation coefficient? So we're going to look at what correlation coefficient is. What is this? So a correlation tells us how two sets of data relate to one another. If there is a correlation, then there's some sort of a relationship. Remember, keep this in mind. Relationship does not mean that one thing causes the other to happen. There is some kind of relationship between the two. The different types of correlation that you can have, and if you think of it in terms of slope a lot of times, I think it helps us realize what kind of correlation you're going to have. So for the first example is a negative linear correlation. You can see, like, if I drew a line here, it would have a negative slope. So we have a negative linear correlation, plus this almost looks like it's forming a line. So we could say it's linear. Same thing over here. This is a positive linear correlation. So it's going up and it has that positive slope look, and it's linear because you could draw a line. It almost looks like a line, so it's a positive linear correlation. Then you have no correlation here, and you can see, like, you can't draw a line. The dots, the points are all scattered everywhere, and there is no like shape to the data points. This is a nonlinear correlation, and it gives you kind of the shape of a parabola, which means it's probably going to be a quadratic. You could also have an exponential, which would take the shape of an exponential function too. So, but this is a nonlinear. All right, so how do we describe a scatter plot? Well, we're going to use correlation coefficient to describe the correlation. You can measure it with what's called an R value. The correlation coefficient is always going to be between -1 and 1, and it tells us how close the scatter plot is forming a straight line. So if you want to pause right here, you can, and fill in some of your paper or draw the points and the little graphs here. Okay, so if you look left to right, so we're going to start with strong negative. This is a -1. You can see how straight of a line that is forming. So that is a very strong correlation. And it's negative. You think about those slopes again, it's forming this negative slope here. So that's why it's strong negative. Now this is a strong negative as well. It's not as strong as this one, so you can see the R value does go down a little bit. And it's still negative. You can still like draw a line through here, line of best fit, and it would be a negative slope. This one's weak, but you can still see looking left to right that your values are decreasing as you move left to right. So it's still going to be negative, but it's fairly weak. This middle one is no correlation here. There is, you can see you can't really draw a line or anything in there, so this has no correlation. Here's another weak, but this time this is positive because if I go left to right, my X values are increasing and my Y values are increasing as I go left to right. This one, I like this strong positive better than the strong negative. I think this shows a little bit tighter. The tighter it is, the more positive and stronger the value is. And then you can see the positive one here. Again, straight line, all those points, they're just, it's like perfect. And that is a strong, very strong positive. This can be the R value sometimes down here, depending on what stat class you take. Strong versus weak. I took a stat class this summer, and the professor, his week was very different from my week when I teach it. So it's kind of up to make sure you're listening to whatever teacher you have or professor you have if you take a stats class in college, and listen to what they think the weak and the positive are. But this is what we're going to use here basing off of our strong and weak. All right, so what's the difference between correlation and causation? So correlation does not imply causation. This is a common phrase that you've heard, maybe you've heard before. Correlation does not imply causation. It means correlation is not causation. Just because there's a relationship there doesn't mean that it's causing it to happen. That maybe it's a coincidence that it happens like that. So here you look, is there causation in this? So it's the number of shorts that are sold and the number of ice cream sales. So look at that, think about that for a second. Is there causation? And for this one, no, there is not causation. Just because, you know, ice cream sales are up doesn't mean that short sales are always going to be up. So one is not causing the other to happen. Yes, the reason being why they're probably both increasing at the same amount is, you know, you eat ice cream probably more in the summer, you're going to buy shorts more in the summer. So that's probably that increase, but ice cream sold year round, and people will buy ice cream year round, and where they probably aren't going to buy shorts year round for the most part. So there is no causation. There's a correlation between the two, but one doesn't directly affect the other. So there is no causation here. So let's look at a couple of examples and decide if we have correlation or causation. So the age of a child and their shoe size. So think if you have, is it correlation? Is it just a correlation, or is there a causation? This one is going to be correlation. And the reason being is, yes, the age of a child, you know, you may think, oh yeah, there's causation. The older you get, the bigger your shoe size. Not necessarily the case. One doesn't directly affect the other. You're going to have people that have really small feet. I am one of those that have really small feet. I can wear a child's shoe size. So that doesn't mean that I'm the age of a child. So it's a correlation there, but one does not cause the other to happen. The number of cars on the road and the number of accidents reported. Think about that. This is a correlation. Again, right now we're, you know, in this pandemic and there's not as many people on the road, but this is something that's really actually happening right now. Yes, the chances of being in a wreck with more cars on the road, yes, there is the chance of that happening. But this is a correlation. One doesn't cause the other. If you look at, I follow a lot of, on Twitter, I like to use it to figure out the traffic that's in Atlanta. And right now, you know, even though I may not be out on the road, be going through my Twitter feeds, and there are wrecks all the time. There are just as many wrecks now, and probably serious wrecks, more serious wrecks than there are, because people are driving faster because there's not as many people on the road. So there are just as many accidents happening now as I think that were happening before. And the seriousness is more. So just because there are a lot of cars on the road doesn't mean you're going to be in an accident. All right, so the next one, the number of sales made and the amount of commission earned. Think about that. A lot of y'all might ask me, like, well, what's commission? Commission is if you go into a store, you may have people that'll come up to you, hi, my name is so-and-so, and can I help you? And when you go to check out, they'll be like, oh, did someone help you today? That's commission. If you buy a car salesman, their income is based off of commission, how many sales they made. So think about that. This is causation because the amount you earn is directly based off of what you sell. So this would be a causation. So I hope you can see the difference between this one and the two previous ones, where this is a causation. A child's weight and the size of her vocabulary. Okay, is it correlation or is it causation? Again, this is a correlation. There's a relationship there that typically as a child gets older, they're going to weigh more and their vocabulary may be larger. But that's not, your weight of a child does not make a difference on what kind of vocabulary you have. So that's going to be a correlation. And last, this one is going to be causation. The number of miles that you drive and the amount of gas that is used. So yes, if you drive a lot, you're going to need a lot more gas. So this is definitely causation here. Okay. All right. I think that's it. Yep. That is the end. You guys have some practice to do, and good luck.